Now come to the another topic. This is called the expanding of the multiplexer. Expanding mean the order of the multiplexer, how to increase the order of the multiplexer. Order means suppose this is the multiplexer, the order is 8 cross 1. That means it has 8 number of inputs and it has always 1 number of output. Multiplexer always has the 1 number of output. So here this multiplexer has 8 input. Similarly, this multiplexer has also 8 inputs. Now, suppose for your design, you required a 16 cross 1 multiplexer. The input line should be 2 to the power something. Okay. It may be 8 cross 1, it may be 16 cross 1, it may be 32 cross 1 like this one. But it should not be 20 cross 1, 10 cross 1 like this. Because these values 10, 20 are not according to the 2 to the power something. Okay. So, in your design purpose, you require a 16 cross 1 multiplexer, but unfortunately you don't have the 16 cross 1 multiplexer, you have the 8 cross 1 multiplexer. So how, using two number of 8 cross 1 multiplexer, how to make a 16 cross 1 multiplexer, and this is called the expanding the order of the multiplexer. Now same as you see the expanding of the decoder, just using the enable input we can able to increase the number of order. Let's see this thing in the circuit maker software. So multiplexer used in this design has active high enable input. The enable input used as the fourth selection line. So using the enable input, we can use that one. And between the two gates, between the two multiplexer, we should put one NOT gate to the enable input. So that means when one of the multiplexer is enabled, due to the presence of the NOT gate, the other one become disabled. So let's check the operation of this multiplexer. So here you see, first understand the circuit. Let's zoom this thing. This is a 74151 multiplexer. That means this is a 8 cross 1 multiplexer. As I mentioned, that 74151 has the 8 cross 1 multiplexer. It has 8 number of inputs, I0 to I7, 3 selection line, S0, S1, S2, 1 enable, 1 active low enable input. So that means you have to give a 0 to enable the IC, to use that particular IC, and it has two output, Y and Y bar. For designing purpose, sometimes somebody required the Y bar, so that means Y bar is also provided by the manufacturer. But if you need that one, then only you use it. Otherwise, if you doesn't need the Y bar complement of the output, you left it blank like this one. And this is the second multiplexer. Second one also 74151, 8 inputs, I0 to I7, 3 selection lines, enable output. And so let's see how to expand that decoder. So the selection line S0, S1, S2 are short circuited. So you see this S0 is short circuited with this S0. Similarly, the S1 is short circuited with S1, S2 is short circuited with S2, and they are brought in a common channel. This is nothing but the S0, this is S1, this is S2. So if we control that S0, the same value is given to the both the multiplexer. Similarly, if we control the value of the S1, it will reflected in both the multiplexer, same as for the S2. Now come to this one, this is the enable, and here the enable input working as the MSB of the selection line. Okay, so this enable input, and this one directly goes to the enable input of the lower multiplexer, because you see no other inputs are connected, no other gates are connected. So this one is directly connected to the enable input of the lower multiplexer, and it is connected after the NOT gate modification. That means its complement is actually connected to the upper multiplexer. Now let's check the operation of this gate, this circuit. If I give the all are 0 0 0, so if I give all 0 0 0, so this is actually a hex display. Hex display means it is actually displaying the value, because sometimes it is difficult to remember what is the combination of the 1010 like this one. So that means for your convenience, I connect one hex display. It actually make the hex of this number and it will show it here. So here you see I give 0 combination. All E, S2, S1, S0 all are connected to 0. So that means 0 is actually given. So if I give a 0, 0 means the blue line and 1 means the red line. So if I give a 0, then our 0 is directly connected to the enable input of the lower multiplexer, and both the multiplexer has the active low enable input. So that means the lower one is enabled right now. and due to the presence of the NOT gate, 1 is connected to the upper multiplexer enable input. But if I connect a 1, then the upper one is become disable because it's a active low. If I give a high input as a enable input, then the multiplexer become disable. So that means in this particular combination, the upper multiplexer disable, the lower one is only enable, and the two output is actually summed together using a 2 input OR gate, and the final output is produced. Here you see that in this 0 0 0 S0 S1 S2, if we keep 0 0 0 combination, then both the multiplexer is actually getting 0 0 0 to its selection line, but the upper one is become disable. So that means the I8, so I8 is actually connected the I0 of the upper multiplexer, but if we change the value of the I8, nothing will happen because this multiplexer is disable, but lower one is enable. So that means if I control the I0 value, then you see the output is actually reflected. If I change the value, toggle the value, the output is also become toggle. So the lower one, so the I0 is now selected as the output. Now if I give the combination 1, you see how 1 is displaying here in the hex display, and it is equal to 0 0 0 1. Similarly, I1 is now selected. Okay, you see if I change any other inputs, then the output is not reflected because it is disconnected. Only the I1 input is connected to the output. If I give any other combination, say 7, then you see I7 is actually connected. Okay, but this one is not connected. This one is also connected to the I7 of the upper multiplexer, but as the upper multiplexer is disable, so it is not reflected the value. I15 is not reflected, only the I7 is reflected. Now if I give 8, then what happened? Then this 0 is connected, this 1 is connected directly to the enable input of the lower multiplexer, and due to the NOT gate, a 0 is connected to the enable input of the upper multiplexer. Now the both the multiplexer of the active low enable input, so that means the upper one is enable right now, the lower one is disable, and the actual selection line combination is 0 0 0. So that means I0 is selected, but not this I0, because this one is disable, rather this I0. So if I select the value of the I8, then it is reflected as the output. Similarly, change the value anything. So you see F means 15. So if I give this combination, then I15 is actually selected as the output. So this whole circuit, it actually has the 16 number of inputs, 4 number of selection lines. So that means, and 1 output line. So that means this whole circuit is a 16 cross 1 multiplexer, but this 16 cross 1 multiplexer is implemented using 2 number of 8 cross 1 multiplexer. So using the lower order multiplexer, we can implement the higher order multiplexer using the help of the enable input. So this is called the expanding the order of the multiplexer.